Hello, John is in the house, and today we're going to talk about the modulus operator. In order to illustrate how to use the modulus operator, I'm going to talk about the hot dog conspiracy. Basically, this conspiracy tells us that providers of winners and buns intentionally force consumers to buy several packages of winners and buns by providing a different amount of winners per package than the amount of buns per package. Let's say you go to the supermarket and you buy a package of winners and a package of hot dog buns. After preparing 8 hot dogs, your remainder is gonna be 2 winners. But if you buy an additional package of buns, you are gonna have 16 buns. And after preparing 10 hot dogs, your remainder is gonna be 6 buns. You fix it by buying an additional package of winners, and after preparing 16 hot dogs, your remainder is going to be 4 winners. If you buy a third package of buns, now you have 24 buns, still 20 winners, and after preparing 20 hot dogs, you are gonna have 4 buns left. But you fix it by buying an additional package of winners. Now you have 30 winners and still 24 buns after preparing 24 hot dogs. Your remainder is gonna be 6 winners. If you buy 4 packages of buns, you still have 30 winners, and after preparing 30 hot dogs, you are gonna have 2 buns left. Finally, if you don't want to have winners nor buns left, you need to buy 4 packages of winners and 5 packages of buns. Of course, the purpose of this video is not convincing you about the hot dog conspiracy, but instead I want to tell you that there is an operator that expresses this phenomenon. In Java, we have the modulus operator represented by the percentage symbol. Basically, we can say that 10 modulus 8 is equals to 2, and this is the way we can say in Java language that after preparing 8 hot dogs, 2 winners are gonna be left. So we can express the next scenario by saying 16 modulus 10 is equals to 6. The same happened to this scenario. We can say 20 modulus 16 is equals to 4, 24 modulus 20 is equals to 4, 30 modulus 24 is equals to 6, 32 modulus 30 is equals to 2, and finally 40 modulus 40 is equals to 0. Basically what is happening here is that the modulus operator gives us the remainder after performing an integer division. So we can say that after dividing 5 between 3, the remainder is going to be 2. After dividing 7 between 2, the remainder is going to be 1. After dividing 7 between 4, the remainder is going to be 3. But theory is boring, so let's go to perform a demo, and what we are going to do is use the YSHL so we can write some instructions in Java language. For example, we want to know what is the remainder after dividing 8 between 5. We say 8 modulus 5, and the result is 3. And we can do the same for other numbers like 81. What is the remainder after dividing 81 between 9? And the remainder is 0. And this is interesting because a common use of the modulus operator is to know if a number is divisible between a second number. For example, let's say I have a number A, and I'm gonna say it is 45, and I have a number B, and I'm gonna say is 5. If I want to know if A is divisible between B, the modulus operator has to return 0. So how can I ask Java if A is divisible between B? I say A modulus B is equals to 0, and Java is telling us yes, true, A is divisible between B because the modulus operator returns 0. And I can change the value of A. Now it's gonna be 46. And if I ask the same question to Java, now Java is gonna tell me no, false, because the modulus operator returns 1, and 1 is not the same as 0. And I think this is enough practice to understand how to use the modulus operator. So we can conclude that the modulus operator calculates remainders after performing an integer division. In Java, the modulus operator is represented by the percentage symbol. And finally, the modulus operator can be used to calculate if A is divisible between B. Thank you for your attention.